Now folks, we've reached Climate Science 5, which is titled The IPCC's Forcing Estimates Are Wrong Too. Now we're sort of delving a little bit into the IPCC and the United Nations. Here we have a representation of the inner workings of the IPCC by the artist Maurice Escher. And it shows people going round in circles, where every path you take, you either end up at a blank wall back where you started, or by standing upside down. So this is typical of the bureaucracy of the IPCC and the United Nations, which results in this among the population of the planet. When they give out their reports, you end up with people like Al Gore, as represented here by this preacher, who terrorizes his congregation with the puppets of the devil, which is carbon dioxide in one hand, and a witch in the other hand, which represents methane. And so you have a woman giving birth to rabbits, another minister thrusts an icon, you get a diseased brain, and of course you have a hysterical crowd. This is of course all religious fervor. And outside the window you have a bemused, pipe-smoking observer. And he's the only sane individual in this scene, which throughout this video will be you and me. Yes, Bob Carter was a great guy. And I also like this more modern representation of consensus science being pushed by the American Association for the Advancement of Science, with the IPCC clown being in the wheelbarrow of consensus science there. Of course, on the left, we've got the skeptical science clown. You all know who that is. And in the background, we've got the NASA clown and the NOAA clown. So that's the current state of climate science. And this is what it has produced. The radiative forcing of climate between 1750 and 2011. This comes from AR5. I will cite this paper for this. What it shows is a massive forcing from CO2, from other well-mixed greenhouse gases, including methane and halocarbons. Another big forcing in red there. Because they haven't quite got the forcing that they thought they should, in reality, so they've thrown in a few little blue ones on the left-hand side here. Aerosols to cool down the climate. Oh, but when that warming comes, when the aerosols dissipate, it's going to be really enormous and dangerous. So this is what we have to deal with, and where is the sun in all this? And that massive orange peak to the right is forcing from total anthropogenic forcings, which totals, as you see, about 2.25 watts per square meter. Since 1750, and all natural forcings put together, including solar irradiance and everything else, but they only count solar irradiance, is that tiny little thing there you can hardly see, which is actually 0.05 watts per square meter. So we'll do a quick little calculation here to see the comparison between anthropogenic forcings and all natural forcings compared. According to the IPCC's latest climate report, the AR5, the Assessment Report 5. Now, they say the anthropogenic forcing since 1750 is 2.29 watts per square meter. And total natural forcing since 1750 is 0.05 watts per square meter. So divide 2.29 by 0.05, we get 45.8, a factor of 45.8. So they're saying that anthropogenic man-made forcings are 45.8 times all natural forcings combined. So in other words, all climate changes are now 98% man-made. So nature has only a 2% influence on climate now. Does that sound correct? We'll check it. Now when the IPCC reports, all of them basically, I would say that there is an enormous mountain of missing science. Now, obvious amongst this missing science is the null hypothesis. A null hypothesis is the default position in any field, but specifically here in the field of climate, And this should be that the current period of global warming or climate change that is now being experienced is almost all natural variability, and so in effect says that there's little relationship between human activity and the observed changes. The possibility that this null hypothesis is the correct one, this obvious one, has never been seriously considered by the United Nations, the UNFCCC, or the IPCC. Now, in the normal course of a scientific investigation, the null hypothesis is generally assumed to be the correct one, unless it must be rejected by the observed data. Most scientists would use the hypothesis testing approach used by Jerzy Neyman, and I cite Neyman 1937, where data within a certain statistical error rate is used to invalidate the null hypothesis. That has never been done in climate science, but perhaps we can use this method to validate or invalidate an alternative hypothesis, i.e. that CO2 is driving climate change. Here is a figure that's an example of this hypothesis testing. You test this new hypothesis by comparing the known temperature curve of the Earth's surface through observations. The green circles here are the average of 4 balloon data sets, and the blue squares are the average of the 2 major satellite data sets against your modeled predictions. Here we have 73 CMIP5 models, climate models, all of which use CO2 as the major forcing, as I said, 98% versus the 2% natural changes, and this is the result. The models, all driven by carbon dioxide and greenhouse gases, are obviously totally wrong, all 73 of them. And just to add insult to injury, the IPCC has added that black line up the middle, which is the average of 73 wrong models. That's supposed to give you the correct answer. So this is how we use hypothesis testing to invalidate a new hypothesis. Now here we've got one of these CMIP5 models versus HADCRUD4, the global in black, the global temperature data set. And this is from the Met Office in the UK, but I could have used any of them. The red line's the Met Office ones, which shows an alarming rise. As CO2 goes up, it's projected to go up, so the temperature is going to go up, but it just isn't happening. Here we can look at satellite data set right up until the present, May 2019. This is the UAH-MSU global temperature anomaly. And from a low in the record, 1979 is when the satellites first started measuring global temperatures. The anomaly was minus 0.1 centigrade, and now it's, plus 0.3. So you've had a 0.4 centigrade rise over the last 40 years. And remember that 1970s was a low in the temperature record, so it's from the 1940s down. Temperature went down to the mid 70s. So over 100-year time scale, the rise has not been. It's been very little, maybe 0.3, 0.5 degrees at the maximum. And this is all related to climate cycles, as I said before in a previous video. Now, why do I say temperature changes presently are all related to climate cycles and not to carbon dioxide? Well, we saw in my previous video, Climate Science 4, that there's no relationship basically on any time scale, no causative relationship between CO2 and temperatures on any time scale. But just during the recent ice ages, there has been a reverse causative relationship. That is that CO2 is like a temperature proxy. It happens a few hundred years after temperature change, CO2 changes, but never vice versa. That hasn't happened. So if we look at other reasons for the temperature changing, we can look, for example, at solar activity. That is a good example. So carbon-14 is a well-known proxy. Carbon-14 concentration in the atmosphere. It's a well-known proxy for solar activity. Carbon-14 concentration in the atmosphere is lower during sunspot maximums and higher during sunspot minimums. Here we can see on the left-hand scale we've got change in carbon-14 in the atmosphere, and along the bottom we've got the last 1,000 years from the USGA of carbon-14 concentrations in the atmosphere. And this comes from tree rings. So we've got the medieval warming period there. We've got the Wolf minimum, then a peak around 1350, 1400. We've got the Spora minimum, then another peak around 1600. Then we've got the well-known Maunder minimum, where the Thames froze over, frozen meters thick, and the ice fairs were held on the Thames. That hasn't happened for centuries. And then we had a rapid rise, the fastest and steepest rise in global temperatures from 1690 to 1780 that we've had in the last 1,000 years. And then just after 1800, we had the explosion of the Krakatoa volcano, the Krakatoa volcanic eruption, which depressed global temperatures for a while. And then modern warming, the modern period of modern warming, continued to the modern maximum. This graph could be temperature. It looks exactly like a temperature graph, but it's not. It's a carbon-14 graph in the atmosphere. It's solar activity. The two are really the same thing. Solar activity causes temperature change on Earth. Solar activity changes cause temperature change on Earth. It's as simple as that. Also, underlying that, you get cycles, climate cycles, and you can see climate cycles appearing here in this graph. Now, in the more recent period, if you like, you can download from HadCRUT, the HadCRUT 3 data. I don't really trust the HadCRUT 4 data, which has been changed and adjusted too much. You can download this, put it into Excel, and you end up with something like this, which is a graph from 1860 to 2014 of the temperatures global. This is global surface atmospheric temperatures. And you can clearly see a peak at 1880, a trough at 1910, a peak at 1940, trough at 1975, and a peak just after 2000, 2002. And this is the 61-year Yoshimura cycle. Very, very well known. And I've put the data into Excel, and here it is here. There's the 61-year Yoshimura cycle. Directly, you can see it in the HadCRUT data. You don't see the CO2 represented in the HadCRUT data. The CO2 trend is not there. The supposedly 98% that's driving all climate change and global warming at the present since 1750 to now, it's not there. But the climate cycles are there in the data. Even so, using CO2-driven models, the CSIRO is predicting by 2070 we'll have 6 degrees of warming. That's that line there. Here we've got Caroli from Melbourne University, not quite so crazy. He's predicting 6 degrees of warming by 2100. That's 2100 there. The graph spans 1850 to 2100. Here's Professor Hughes, another alarmist, slightly less crazy than the others. He's predicting 4 degrees increase by 2100. And this cycle here is the 60-year Yoshimura-Gleisberg cycle, just continuing onwards up to 2100. And that's what I'm going to stick with. There's 1000 for all his prediction there. Temperatures will be about the same as they are now in 2100. Okay, and this is another projection of future temperature rates by Scafetta using climate cycles. Here in blue is his projection with the black line in the middle. And here you can see the actual temperatures in red and blue going across there. And up there in green, that's predictions from the climate models using CO2 as a forcing. You can easily see which is the better of the two. This is a more updated version of Nicholas Scafetta's climate cycles projections, including the 2016 El Nino, which did temporarily dip into the computer models projections, but now it's back down at an anomaly of 0.3 degrees, so it's down here somewhere at the moment in 2019. So how did all this go so wrong? How did the IPCC get it so wrong? Basically, it all started in 1988 with Jim Hansen. He's the one that said, he's the one that got his PhD thesis on the basis that Venus has a runaway greenhouse effect, something that I've shown to be incorrect. Hanson's well known for his 1988 testimony to Congress on a sweltering hot day, June 23rd, 1988. He turned off the air conditioning to make the place even hotter, and then he put forward his nonsense. The Earth is going to be sweltering with a runaway greenhouse effect and finish up like Venus if we don't stop our CO2 emissions. He made projections using CO2 into the future. All his projections have been proven to be completely wrong. Now, in the 1980s, climate science was a relatively small field. It's hard to believe it now. That's where the present null hypothesis of climate change came from, the one that they assumed. They assumed, without any empirical evidence, that there is a tropospheric greenhouse effect, meaning that anomalous warming from greenhouse gases like CO2 warms the troposphere and causes significant net warming, even though this hypothetical warming has never been empirically measured, quantified, and then attributed to greenhouse gases in any published peer-reviewed scientific study to date. So the end result was decided before the science was even done. Now, the existing null hypothesis of climate change simply assumes that there exists a 33 degrees centigrade residual warming effect, which in turn is assumed to be 100% produced by greenhouse gases in the lower troposphere. More assumptions are that once CO2 is emitted by humans to the atmosphere, it remains there for hundreds or even thousands of years. Now, why is the present null hypothesis for climate wrong? Well, it was merely assumed in the 1980s, as I say, by Hansen and the few other climate scientists that existed on the planet at that time, that CO2 was driving climate change and there was a greenhouse effect. I think that this assumed null hypothesis is invalid for those reasons, that it includes a very significant influence from an effect which has merely been assumed and has not been empirically detected, quantified, or attributed, and has not been shown to exist in the real atmosphere, namely the anomalous tropospheric warming from the so-called greenhouse gases has not been detected in the real atmosphere. So the present null hypothesis of climate change needs to be immediately replaced with one that is based fully on empirical science, that adheres to the laws of thermodynamics and to the gas laws, and to atmospheric phenomena which have been measured, quantified, and attributed. Okay, it's time we started to look at the problems with the IPCC's forcing, relative forcing, that 98% supposed to be man-made forcing and 2% from nature, which is 0.05 watts per square meter since 1750 to the present, all caused by the sun, apparently. So let's we'll concentrate on that 0.05 watts per square meter forcing increase by the sun since 1750. Now, their argument is that changes in TSI are only 0.01% during a Schwab solar cycle. And I cite Foukal et al. 2006 for that. And that the change in TSI is too small to have caused the 0.8 degrees centigrade of global warming that has been allegedly measured since 1750. My reply is that the temperature rise is historically not unusual. The TSI range is greater than that which is generally assumed. Amplifying mechanisms exist for solar activity changes, including for TSI through the cosmic ray cloud link. The sun has other climate forcing agents acting for it apart from just TSI. The greenhouse effect in the troposphere may be smaller than is thought due to a tropospheric temperature gradient caused by autocompression. Many of the climate cycles exist apart from the one quantified by the IPCC. And last but not least, the recent natural variability is much greater than is shown by, for example, tree ring proxies. Now, what I would say is the real null hypothesis of climate change, the one we need to switch to, would actually include cosmoclimatology. Discovered and named by Professor Henrik Svensmark, and I cite his paper here. Now, prominent scientists who are proponents of this cosmoclimatology hypothesis are Henrik Svensmark, Nils Schwiv, Jan Weiser, Sebastian Lunig, Fritz Fahrenhalt, and Nigel Calder, among others. Now we're going to come back to cosmoclimatology in another video because, I mean, it's just massive, that subject alone. Now we're going to look at my first point, which is that this temperature rise is historically not unusual. Now, a recent study of Holocene climate changes in Asia lends support to the proposition that the present global temperatures are nothing unusual, and I cite Eisen 2016, and are in fact lower than the majority of the Holocene period, and I cite Rosenthal 2013. Recent research indicates that the medieval warm period, especially around the year 1300, that's just 700 years ago, was 0.5 degrees centigrade warmer than the present is. For example, in Scotland, and I cite Rydval 2017. Also in China, and I cite Zhang 2015. Rydval's temperature reconstruction from Scotland reveals that the warmest 5 years since 2000 were in order 1284, 1285, 1307, 1310 and 1282. Nothing in the current warming period. Their reconstruction shows that the current warming period was easily exceeded by the medieval warming period, centered on the year 1300, and is similar only to several other more recent warm periods, such as the ones around 1500, 1730, 1880, and 1940. And here is the figure for that from that paper. Now, the de Vries Swiss climate cycle, which peaks about every 210 to 240 years, is clearly represented in this reconstruction, as it is in several others. The 61-year Yoshimura climate cycle is also there, with recent peaks in 1880, 1941 and 2002. Now, I have to emphasize that none of these climate cycles and none of these papers are in any IPCC report. Now, nevertheless, there's considerable evidence that both the Roman warming period and the medieval warming period were warmer than the current warming period, the period that's called global warming by the IPCC, and were global. South Sea China temperatures, I cite Yan, Sun, Shao, Wang and Wei, 2014. China in 1300 AD, I cite Zhang, 2015. Central European temperatures in 1540, I cite Orth et al. 2016. Middle Eastern temperatures 900 to 1900, I cite Kaniowski 2011. European Alps, I cite Laduri 1975. Lam 2013. Australia, I cite Toza 2016. Tibet, I cite He et al. 2013. The Pacific and Atlantic Oceans, I cite Rosenthal 2013. It can go on and on. Now, an interactive map of all these papers, an interactive map has been constructed by Professor Varenholt and Professor Lunig, which lists the mass of 951 published scientific papers, underpinning the robustness of the medieval warming period from every corner of the globe. Needless to say, this totally disproves man's hockey stick. And this leads to the inescapable conclusion that the current warming period is well within the range of natural variability. And just to emphasize the point that the current warming period, 1690 to the present, is nothing unusual or out of the ordinary. We don't have to compare it just to the medieval warming period when it got warmer, but we can compare it to the Roman warming period, the Minoan warming period, and many other warming periods before that in the Holocene. You can count 7, for example, on this GISP2 temperature graph from Greenland. So roughly 0.8 degrees centigrade we've seen in rising global temperatures since 1690 is not really unusual and not surprising when you consider that solar activity was higher in the late 20th century than it's been for at least 4,000 years and probably for 11,000 years. That little green line is what we've seen over the last 300 years, the current warming period, or the modern warming period some people call it. So what are we trying to show? That this temperature rise is historically not unusual. I think we've confirmed that. So that can be crossed off. Now next we're going to look at the TSI range and as I said before, the IPCC has ascribed a TSI increase of just 0.05 watts per square meter to the Sun since 1750, which sounds pretty small, really. So we're going to check that TSI increase and see if it accords with the literature. Now I'm going to show you a few genuine hockey sticks this time. This is Sunspot Numbers by Ledecky, published in 2011. I cite them here. And this is over the last 2,000 years. And sunspot numbers is absolutely related to solar activity. You can see that it's drifted downwards until about the year 1700, or I would say 1690. And then it's took off dramatically to an enormous, several times what it's been for the last 2,000 years. And here's another paper. This one is by Hoskin, 2007, and I cite that paper. Now this goes back 11,000 years, not just the last 2,000. And the solar activity at the moment, you see the peak there on the right, that's the current level of solar activity. It's higher than it's been for 11,000 years. Now, when the solar activity peaks into the red, that's a grand maximum. When it goes down to the blue, that's a grand minimum. Now, in the late 20th century, the Sun hit a grand maximum. As I said, higher solar activity than thousands of years and probably for 11,000 years, according to their paper. Now, does that sound like a 0.05 watts per square meter increase since down here, since the depths of the Little Ice Age in 1690, up to the massive peak at the top of the grand maximum at the end of the 20th century? I don't think so. Let's look into it. Okay, first I have to say there's a bit of an esoteric argument among solar physicists about whether the P-mod or ACRIM TSI composites are to be used for a base TSI level. I'm not going to get into that today. What I want to show you is what the IPCC use for their solar forcing. And this is it here, basically. This is what they're using. And as you see, it shows a range since 1750 to the present of no more than 2 watts per square meter, from 1360 to 1362. And the current level is shown to be around 1361 watts per square meter. Now, you can see that since 1750, that's the date they use for a start date. You've got to watch out for these things. And of course, they've cited the start TSI as about the same as it is at the finish. Okay, now we'll look at some other TSI reconstructions. This is one by Scafetta and Wilson in 2014. Goes back a little further, as you see, goes back to 1700. And even then, before that, as I said, in the late 1600s, the TSI was lower than that. So if they went back a little further, it would be even lower than it shows here. Starts off at 1357, anyway, around 1700. Makes a massive rise up to about 1760, the year 1760, up to about the current levels of 1361 watts per square meter. So it's already at current levels in 1760. This is where, they use the pre-industrial level. They cut off everything at 1750. It's the same sort of thing that they use to measure the temperature data when they started in 1979, which is a low in the record. They started here with TSI in 1750, which was a high in the record. They've cherry-picked dates to suit themselves for a start. Now, that's only the start of the problem here. The other problem is the range of the data. Look at Scafetta and Wilson's range here, 1357 up to 1362. So they've got a range of 5 watts per square meter, whereas the T-Metal that the IPCC uses has a range of less than 2 watts per square meter over the entire record. Other reconstructions have an even bigger range. This is one by Shapiro in 2011, which shows a range from 1353 to at least 1363, so more than 10 watts per square meter. But this goes back further. It goes back to 1000 AD, so it goes back 1,000 years. And if we just look back to, say, the late 1600s, the depths of the Little Ice Age, we've got about 1353 to 1354 as a TSI And then again that massive increase up to the year 1760, where it's roughly at current levels. So this is where the IPCC basically get their tiny little 0.05 watts per square meter from by cherry picking the start date. Now if you're wondering about this reconstruction, it has been confirmed by Herrera et al. In 2015, and I cite their paper as well here. Okay, so this is what has caused it when you're having a discussion with an alarmist online and he says, we know it isn't the sun. This is what he's talking about. 0.05 watts per square meter of forcing. Whereas in reality, this is what it is. So if we take, let's say, for example, this chart here as being correct, we should really go from 1690. 1353.5 watts per square meter for a TSI. Top of atmosphere insulation forcing. So rather than cherry picking the top, let's try the bottom for once. 1353.5, take that off 1361, the current level, you get 7.5 watts per square meter of forcing. Now that's not at ground level, so we have to multiply it by 0.7, which is our albedo, and divide it by 4. And that gives you the surface level of insulation, which is 1.31 watts per square meter. 1.31 watts per square meter is a lot. You divide that by 0.05 and you get a factor of 26.2. So the IPCC are out by a factor of 26 on their estimate of 0.05 for TSI for the sun. Change, instead of 1750 to the present, if you use 1690 as a start date to the present, and you use these other researchers' data instead of the IPCC's researchers' data, then you get a 26 times bigger TSI forcing, a factor of 26 times bigger. So now that's only the start of it. As I said, that's the TSI. We haven't dealt with CO2 yet, they're forcing on the opposite side. But anyway, we can cross out the second part here, which is the TSI range is greater than that which is generally assumed. Now we're going to have a quick look at Svensmark's cosmoclimatology for an amplifying mechanism which is, he suggests it exists for solar activity changes, including for TSI through the cosmic ray cloud link. Now the natural or default null hypothesis that I would say we should be using generally includes the cosmic ray and cloud hypothesis along with autocompression and so on, called cosmoclimatology. Now it involves an amplifying mechanism that acts through a solar activity cosmic ray to low cloud link on short time scales and through a galactic cosmic ray to low cloud link on longer time scales. So the surface temperature is therefore altered by albedo changes through clouds. So cosmoclimatology says that the flux of cosmic rays of the right energies, those which are powerful enough to create a cascade of muons and other relativistic particles through the atmosphere that can reach the Earth's lower atmosphere, is moderated by the strength of the solar magnetic field and the solar wind. And I cite Svensmark and Fritz Christensen 1997, and the quantity and reflective properties of low clouds are changed by those cosmic rays through the resultant muon shower's ability to seed those clouds or to change their properties, for example in the area of reflectivity or whiteness, by generating aerosols or cloud condensation nuclei. The properties of low cloud are changed by the production of CCNs of a smaller size than those which would otherwise naturally occur. Now the Earth's magnetic field plays a much smaller role than cosmic rays in this, because they appear to be only capable of affecting only 3% of the average cosmic ray flux. So this hypothesis puts clouds at the very center of climate change in cosmoclimatology. Clouds are not the small bit players that are unsuccessfully modeled and are just there as they are in the climate models of our friends in the CO2 proponents area. Clouds actually determine surface temperatures. Now you can see a perfect example of the low cloud to temperature link in this graph here, which shows Hadkrut 3 and the level of tropical low cloud cover in the 15 north, 15 south part of the atmosphere. And you can see that there's a strong correlation between tropical cloud cover and global surface air temperatures. Scatter diagrams of low cloud cover versus global surface air temperatures indicate that a 1% fall in low clouds equals a 0.06 degrees centigrade rise in surface temperatures. Hence, a 6% fall in low cloud cover, as we see here, equates to a roughly 0.36 degrees centigrade rise in global surface temperatures, and that's just about all of the observed rise seen here in the Hadkrat 3 data over this time period, which is 1983 to 2000, I would say. In general, it's possible to say that high clouds have a warming effect and low clouds generally have a cooling effect, except at night and over the Antarctic and Greenland. Now, overall, clouds cool the Earth, and the effect is not small. It's about 20 watts per square meter, according to SMIP5 2007. Now, it cannot be both ways. We cannot have a sun like the IPCC makes out that has very, very small effect on climate. TSI changes are small, and recent historical, decadal, and centennial climate changes therefore must have also been very small, like the hockey stick, for example. No change for 1,000 years. TSI variations must have been at least 3 times larger, and I cite Foukal et al. 2006, than is stated in the IPCC reports. Otherwise, for an example, the severe Little Ice Age cooling centered on 1690 would not have been possible. So the TSI changes were not really that small. And probably a strong amplifying mechanism exists as well as the much larger TSI changes. How much is this amplifying link from cosmoclimatology? Astrophysicist Neyman has investigated this in a brilliant way. He used the oceans as a calorimeter, and I cite Shaviv 2008. His findings indicate that the total radiative forcing changes were actually 5 to 7 times greater than just the TSI variations alone. So we've not only got bigger TSI variations, but we've got an amplification due to cosmic climatology. Now, the largest of these amplifying mechanisms were through the cosmic ray flux cloud link, specifically involving a galactic cosmic ray flux of high-energy protons of over 1 GeV. These are the ones with enough energy to reach low tropospheric clouds and influence them through muon bombardment. There is a mountain of evidence supporting this. For example, there's a strong correlation between the cosmic ray flux and climate on many timescales. I cite Nefertal 2001. So we now have a lot of scientific evidence here to say that the TSI range is greater than that which the IPCC assume at 0.05 watts per square meter from when industrialization started, and it could be up to 26 times greater than that. But in any case, it's at least 5 to 7 times greater. That's just the TSI change. We know that in the late 20th century, we had the high solar activity for at least 4,000 years and possibly up to 11,000 years. And there are consequences to that much higher solar activity, the solar maximum we had in the late 20th century. On top of that, there is an amplifying mechanism through cosmoclimatology, which SMIP5 puts at 5 to 7 times on top of the TSI change. Now, of course, if anthropogenic greenhouse gases are driving climate change or global warming to the extent of 98% right through the period of industrialization, then there should be a really great correlation between rising greenhouse gas concentrations in the atmosphere. How is it possible to reconcile the flat and then the exponential growth rate of the main climate driver, CO2, with a rapidly varying surface temperature graph? Can such large and cyclic variability be possible if natural variability really has only a 2% impact on the changes in the last 260-odd years? There appears to be very little connection between the alleged CO2 growth curve and the rapidly varying measured and proxy temperature graphs. Difficulties arise with the stated overall total solar radiance, TSI forcing, of 0.05 watts per square meter in AR5, because when the scientific literature is examined, very different numbers are found there. Now, the IPCC attached very little importance to the sun right from the start, because astrophysicist Judith Lane, she was the only astrophysicist contributor for many, many years to the IPCC. Of course, if the effect of the sun is more, then the effect of the greenhouse gases has to be less. If you increase the 2% effect, then you have to reduce the 98% effect. Now, according to Solomon, 2007, the oceans can absorb 1,000 times more heat than the atmosphere. And when we look at the temperatures since 1900 of the sea surface and the near surface, there's no correlation with CO2 at all or greenhouse gases. But there is a definite correlation with the known climate cycles. Here are ocean temperatures since 1900 by Goretzky, Kennedy, Boyer and Cole, 2012. And by comparison, the land measurements since 1900 shows no significant warming at all. This is a paper by Lansner and Pedersen. Of course, according to the greenhouse gas theory, increasing greenhouse gas concentrations in the troposphere should cause a hotspot, roughly over the equator in the tropics at about 10 kilometers in height. But radiosonde measurements, 1979 to 2012 of the tropics, show no hotspot at all at 12 kilometers. In fact, if anything, there's a slight decline in temperatures at that height. In the last 2,000 years, there have been 3 warming periods: the Roman warm period, the medieval warm period, and the current warm period. Now, these 3 warm periods were all at a similar level, and I cite Abbott and Marahasi, 2017. Now, yet according to the IPCC, the greenhouse gases that are supposedly driving 98% of climate change and global warming were flat until just the last half of the 20th century. So how did the Roman warm period and the medieval warm period happen? As we've seen in other videos, the greenhouse effect in the troposphere may be much smaller than is thought, maybe even zero. This is all down to climate sensitivity. Climate sensitivity over the years has been getting lower and lower and lower in the literature, but it hasn't changed in IPCC reports. They're still reporting between 1.5 and 4.5 with an average probability of it being 3 degrees centigrade. But in the literature, as you see here from these papers, it's been getting lower and lower. Of course, if it does get down to 0, that means that there's no greenhouse effect at all from greenhouse gases. So they do not essentially affect temperatures. That's what it means. We've seen in other videos that there's many other climate cycles apart from just the one that's been quantified and used by the IPCC, which is the 11-year Schwab. There's at least another 15 climate cycles that they've totally ignored. Some are very, very, very relevant on the time scales we're talking about, the last 100, 200 years. And recent natural variability is much greater than is shown by tree ring proxies, as you see from this peer-reviewed paper here, which I cite. So to sum everything up, once we look at all this evidence, the 98% anthropogenic versus the 2% natural, it seems like that is at least the opposite of what it should be. It should be 98% natural at least, and 2% as a maximum for anthropogenic. That's the top and bottom of it. Thank you.